Welcome to Algebra 2, Unit 6, Lessons 5 and 6 practice problems. The picture shows points on a unit circle labeled A, B, C, and D. Which point is cosine pi over 3 sine pi over 3? So if you remember, pi is half a circle. And since a circle is 360 degrees, pi is 180 degrees. So that means pi over 3 is 60 degrees. So we're looking for a point that appears to make a 60-degree angle. A looks to be less than half of this quarter, so this is probably about 30 degrees. B does appear to be about 60 degrees, so B is going to be the correct answer. C appears to be about 30 degrees before a full circle, so we would say that this is about 330 degrees. And D appears to be about 30 degrees past 3/4. So if 3/4 was 270 degrees, D appears to be about 300 degrees. So we're looking for pi over 3, which you could think of as half of a circle divided into thirds, and notice that that looks like B, or you can know that pi over 3 would be 180 degrees divided by 3, which equals 60 degrees, and then you would know that point B is the correct representation. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. On page 2, for which angles is the cosine positive? Select all that apply. So what I want you to think about is a unit circle. And we know that if we were to draw a right triangle, we can use the Pythagorean theorem. And we're looking at this angle here. So if we zoom in on this, we have angle theta. And cosine equals adjacent over hypotenuse. So if I'm looking at this angle and I'm on a unit circle where the hypotenuse is 1. This is my x measurement, and this is my y measurement. Then my adjacent is my x value over my hypotenuse, which is 1. And anything over 1 is itself. So our cosine is our x value. So if we want x to be positive, then we need to be on the right side of the y-axis. So now if we draw a new unit circle to look at, point A is at 0 radians. That is our starting point where x equals 1. X is positive, therefore cosine is positive. So A is a correct answer. At B, we have 5/12 pi. If you remember, pi is half of a circle. And 5/12 is going to be less than half, because 6/12 would be half. So if we are not even to halfway, then B would be right about here. So B would also be a correct answer. Next, choice C is 5/6 pi. So if pi is half of a circle, 3/6 would be halfway, so 5/6 would be right about here where the orange dot is. Well, point C is going to have a negative x value, therefore cosine is going to be negative, and C is not a correct choice. Choice D, 3/4 pi. Again, pi is half of a circle. 2/4 would be halfway, so 3/4 is going to be halfway between half pi and full pi. So point D would be right here where the green is, and x is negative on this side of the y-axis, so cosine would be negative. So D cannot be a correct answer. And finally, choice E. We have 5/3 pi. So pi is half the circle, and that would be 3/3. And now we need to go another 2/3, which would put a point down here in quadrant 4, where I put this purple point and labeled it E. On the right side of the y-axis, the x's are positive, therefore E is also correct, because if the x is positive, the cosine is positive. If you have any questions about how I solved this practice problem, Please use class time now to ask for further clarification. Mark two angles on the unit circle whose measure theta satisfies sine of theta equals negative 0.4. How do you know your angles are correct? So the first thing I want to point out, if we have a unit circle and we draw our right triangle, we have angle theta. Remember that this is our x value, how far it goes over, and this is our y value, how far it goes up, and our hypotenuse is always 1. Sine equals opposite over hypotenuse. Well, if the opposite side is y and the hypotenuse is 1, then sine equals y. So what we're saying is that y needs to equal negative 0.4. If this is a unit circle, then each of these lines is a 0.1. So if I go down, I have negative 0.1, negative 0.2, negative 0.3, and right here I have negative 0.4. So if I go out to the left, I have a point right here. So if I draw the line connecting it to the origin, then this angle right here would be one of the points. Next, if this is negative 0.4, I go out to the right and I have my point right here. And now I can draw the line that connects it to the origin. And this angle comes all the way around until it hits this line. So these are two angles on the unit circle whose measure theta satisfies sine of theta equals negative 0.4 because they end up with a point where y equals negative 0.4. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. For which angle measures theta between 0 and 2 pi radians is cosine of theta equal to 0? Label the corresponding points on the unit circle. So we need to remember that cosine theta equals x. So if cosine theta equals 0 and cosine theta equals x, then that means x equals 0. And x equals 0 on the y-axis. So we have a point at the top that we'll call point A, and the angle measurement at A is pi over 2 because it's half of pi, because pi is half a circle. Then we're also on the y-axis down here at the bottom, and we'll call this B. And here we would call the angle for point B 3/2 pi, because we have a full pi, which is 2/2, and then we have another half of pi. So these are the two angle measurements, pi over 2 and 3 pi over 2, in which x equals 0 because we're on the y-axis. Number 2. What are the values of sine of x for these angle measurements? So you have to remember that sine of x is equal to the y value. So for point A, sine of x equals +1 because it's up here at the top where y equals 1. And for point B, sine of x equals -1 because it's down here at the bottom where y equals -1. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. The picture shows angles A and B. Explain why sine of B equals negative sine of A, and why cosine of B equals negative cosine of A. So A and B lie on opposite ends of a diameter of the unit circle. So they have opposite signs. Point A is going to have coordinates x, y, because in quadrant 1, x is positive and y is positive. In quadrant 3, point B is going to have negative x, negative y. So when we try sine of b, sine of b is going to equal negative y. Sine of a is going to be positive y, but now you're going to have negative y. Cosine is the x values, so cosine of b is negative x, and negative cosine of a is going to be positive x, so now that becomes negative x. So now negative y equals negative y, and negative x equals negative x. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Which statements are true? Select all that apply. So notice A, B, and C are asking about quadrant 2, and D, E, and F are asking about quadrant 3. So in quadrant 2, x is negative and y is positive. In quadrant 3, x is negative and y is negative. So sine equals y, and y is positive. Cosine equals x, and x is negative. And tangent equals y over negative x, so it is negative. So as we read, A says sine is greater than 0, which means sine is positive. Sine is positive y, so A is correct. B says cosine is greater than 0, which means cosine is positive. That's not true. Cosine is negative x. And C says tangent is greater than 0, which means it's positive, but tangent is y divided by negative x, and a positive divided by a negative is a negative. So A is the only correct choice out of the first three. Now in quadrant 3, sine is the y value, so that's negative y. Cosine is the x value, so that's negative x. And tangent is the negative y divided by the negative x, which means a negative divided by a negative becomes positive. So D says sine is greater than 0, which means sine is positive. That is not true. Sine is negative. E says cosine is greater than 0, which means cosine is positive. And that is false because negative x is cosine in quadrant 3. And then F says tangent is greater than 0, which means tangent is positive. And that is true because a negative divided by a negative equals a positive. So A and F are the correct answers for this practice problem. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. The tangent of an angle satisfies tangent of theta equals 10. Number 1. Which quadrant could theta lie in? Explain how you know. So first, you have to remember that tangent equals y divided by x. So if tangent is positive, we either need positive x, positive y, or we need negative x, negative y, because a positive divided by a positive is a positive, and a negative divided by a negative is a positive. So for number 1, theta could be in quadrant 1, where x is positive and y is positive, or in quadrant 3, where x is negative and y is negative. Number 2. Estimate the possible values of theta. So if you think about it, quadrant 1 is in the upper right. On the bottom of it, x is 1 and y is 0. And we can't be at that point because 0 divided by 1 would just be 0. But if we were really close down here, we could be at 0.1 divided by 0.9, which would equal 0.11. And that's not close to 10. So we don't want to be down towards the bottom part of quadrant 1. But if we're up at the top, we can't be exactly at the top either, because this point is 0, 1, and we would have 1 divided by 0, which is not allowed. You cannot divide by 0. But if we were really close, we could be at 0.9 divided by 0.1, which would be 9. So we're somewhere really close to the top of quadrant 1. So theta would be close to pi over 2, or in quadrant 3, you're down in the bottom left. If we're over here, then our point is at -1, 0. And if we get really close to that, we could be at -0.9 divided by negative 0.1 divided by negative 0.9, which is going to be negative 0. Or positive 0.11. That's not close to 10. But if we're really close to the bottom here, where x is 0 and y is negative 1, now we're really close to the point of negative 0.9 divided by negative 0.1, which would again equal 9. So we can't be exactly at the bottom, but we could be close to it. So theta would be close to pi over 2, or it would be close to 3 halves pi. Either we're really close to the top of the unit circle, or we're really close to the bottom of the unit circle in order for tangent to equal 10. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. On page 4, it says evaluate each of the following. In order to do this, we need to understand a special type of triangle. We call this a 45, 45, 90 triangle. We have a right triangle with two 45-degree angles. And when we place this on a unit circle, the hypotenuse is 1, the y is square root of 2 over 2, and the x is also square root of 2 over 2. So as we think about these, tangent of 5/4 pi is going to be five-fourths takes us all the way to pi, and then halfway through quadrant 3. So now we have one of these 45, 45, 90, where the x is negative and the y is negative. So if tangent is y over x, and they're both negative, this is going to be negative square root of 2 over 2 over square root of 2 over 2, and anything over itself is 1. So tangent of 5 pi over 4 equals 1. Next, we have sine of 3 halves pi. Well, 2 halves pi is pi. Now we need another half, so we're down here at the bottom. And sine is the y value. And at the bottom on a unit circle, your y value is negative 1. And finally, number 3, we have cosine of 7/4 pi. So 4/4 is going to take you halfway around the circle to pi. Now I need another 3/4. That's going to bring me around until I'm halfway through quadrant 4. In quadrant 4, my x is positive and my y is negative. And I've got another one of these special 45, 45, 90 triangles. So if my cosine is my x and my x is positive, then this is going to be square root of 2 over 2, because that's what the x is on a 45, 45, 90 right triangle. If you have any questions about how I solved this practice problem here, please use class time now to ask for further clarification. The sine of an angle theta in the second quadrant is 0.6. What is tangent of theta? Explain how you know. So if you remember, x squared plus y squared equals the radius squared. Well, now we want to integrate trigonometry with the Pythagorean theorem. Since x is cosine, we can say cosine squared. And since y is sine, we can say sine squared. And the radius on a unit circle is always 1. So cosine squared plus sine squared equals 1. Now, we don't know cosine squared, but we do know that sine is 0.6. So we can have 0.6 squared, and this is going to equal 1. Well, 0.6 squared is 0.36. Now we're going to subtract 0.36 from both sides. And that gives us cosine squared equals 0.64. If we take the square root of both sides, then cosine equals 0.8, because 0.8 times 0.8 equals 0.64. So now I know what sine is, and I know what cosine is, and I know that tangent equals sine divided by cosine. So now I have 0.6 divided by 0.8, which is the same thing as 3/4. But we are in the second quadrant. And in the second quadrant, x is negative. So this means that our cosine is actually going to have a negative, which means our 4 has a negative. So our tangent is actually negative 3/4. If you have any questions about how I solved this practice problem, please use class time now to ask for further clarification. Which of the following is true for angle theta? Select all that apply. So for point P, we are over here in quadrant 3. And in quadrant 3, we're going to have a negative x and a negative y. So A and B go together. Only one of them can be true. A says that sine, which is our y value, is less than 0. And that's true. Our y value is negative, so A is correct. Then we have C and D. Only one of them can be true. Cosine is our x value, and our x value is negative, so cosine must be less than 0. So choice C is correct. And then finally, E and F go together. E says that sine, which is our y value, is greater than cosine, which is our x value. And F says the y is less than the x. So if you look, our x value is this close to -1, but our y value is only this close to -1. Our x value is less than our y value because as you go left, your negatives are getting bigger, you're getting smaller. As you go down, your negatives are getting bigger, you get smaller. But the x value is smaller than the y value, so the cosine is smaller than the sine, so that means choice E is the correct answer. If you have any questions about any of the practice problems that we did on this worksheet package, please use class time now to ask for further clarification.